In South Africa, we look at parabolic antennas with the receiver in the middle. They look at higher frequencies, so meaning from 350 megahertz all the way to 50 gigahertz. It's a dry area, very deserty. We chose this for scientific reasons because urban areas will introduce RFI, so which is radio frequency interference, so away from GSM, Wi-Fi, and so on. So we don't actually get to interfere with the telescope observations. The first 4 dishes are going to be in addition to the existing Meerkat telescopes in there, which is operated by South African Radio Astronomy. When the whole telescope is built together and finished, we will talk about hundreds of kilometers spreading across South Africa. Over the lifetime of the project, we are looking at building 197 dishes. First 4 dishes, we'll be able to put the whole system together. We will learn more about our own system. We have to allow a learning period where we test and verify the project. And then if it doesn't work as intended, we then modify the dishes before we move on to the next milestone. So in China, we are working with CETSI 54. It's a Chinese Institute for Electronics and Communications. And then CETSI 54 is based in Shijiazhuang, which is just an hour south of Beijing by fast train. We've just witnessed the first production dish being put together in China, which is going to be replicated in South Africa. So what they've done in China is putting the pedestal, the main reflector, sub-reflector, dish control system together. It was nice to see that all coming together and everything fitting as expected. And then it will give us confidence that whatever we're going to build in South Africa will be working as expected.
The first dish being integrated here at CETSI 54 can produce more time for SK construction. The shipment of second antenna is about 2 months, but using this antenna, we can bring the verification test ahead. Eventually, it will be assembled again in South Africa with other 3 antennas. The challenging is we need to keep the posture and position of major components precisely. We have been working with SKO to establish a solid integration and verification process to help us manage this risk.
This is the anechoic chamber. It's for testing the RFI performance of the devices. This is the receiving antenna. Operating frequency is 50 megahertz to 1 gigahertz. And this is from 1 gigahertz to 18 gigahertz.
We are lucky CETSI 54 joined the project at the very beginning. We learn more during the project. We discussing with the astronomer, a scientist very closely. Science and technology industry can improve each other by this project.
To build a dish like this is not an easy task for anyone because it's not just only one person building this. You collaborate with a lot of other people from different places. When I got to witness and see the system being put together and then see the performance, it was a great sense of feeling of achievement. Maybe one of the primary goals of the SKO project is science and learning more about the universe and so on. But one opportunity that I think I've learned to appreciate is people. You know, everything that you do in terms of technology, engineering, it's all to serve people, really. So for me, if we can learn how to work together with people all over the world, knowing that really, fundamentally, as people, we are all the same.